Hello everyone, welcome to the online demonstration video for the International Invitational Competition on Smart Remote Chemical Engineering Experiments for university students. This video will explain how to sign the system, operate the remote experiment platform, and end the experiment correctly on the competition day. In this competition, you will remotely operate a real experimental unit. You will manually control the on-site destination unit through the web-based interface. Before the experiment, you have to log into the Tencent meeting and the operation system 15 minutes before the competition starts. Each team is allowed to use only one account and one computer to sign and operate the system. Please turn on the front-facing camera on your computer and share your screen in Tencent meeting. Your camera and screen sharing should remain on until the end of the competition session. Please use a stable internet connection. A wider connection is preferred. If you use Wi-Fi, 4G or 5G, please make sure that the connection is stable enough. Please use Chrome or Edge and turn off the browser translation function and other antivirus software. During the competition, you may use the printed reference materials, but electronic reference materials and other electronic devices are not allowed, but the calculator is okay. We can open the platform link provided by the organization committee. So that is new.oberyn.com and tdin login and enter the username, password, and the verification code assigned to the team. So now I just use this one to continue. Okay. So after signing, enter the assigned computation workplace and select the corresponding remote experiment item. Right now it's some test workspace, so now we choose this one. But for the computation today, so there will be a formal workplace, and you only one, I think. So in that you can choose that one. So right now I use this one for continue, and so here we have the experiment numbers, destination line, and for your computation there will be one assigned to you. On the left, this is a live video for the on-site equipment device. So we can full screen that to see it. So, and on the left, there is actually the flow chart of the destination experiment and also the control panel of it. So if we zoom it, now you may notice that so to see it clearly, okay, and we back it and we can control it firstly. Take the control and we can take the start, click the start button to continue to control the experiment. So this button stop, that means you can stop a minute and then you can start again. Okay, that's okay. You can click stop this button during the computation. That's okay. And this button, the end button, that means the end of the experiment. Before you finish the experiment totally, you must click this one. But during the experiment, during the computation, please do not click it. Okay. If you really want to stop and end the experiment, you have to, and you must click this one before the computation end. So right now we just zoom, and we can full screen that. So on the left, there will be some temperature trend and some pressure and flow and the level trend. All of these things are very important. So you may click it and find what's the meaning of that. And for instance, for this one, P1, for this one, temperature trend and we can choose other temperature and click search, and all these temperature trend will be shown in this figure. And on the so we have the ethanol and the propanol mixture contained into this feed tag, and we just deliver them by some feed pump, and into the destination tower directly to the column. We can go to the PV3 or PV4, or we can make the mixture into the reboiler or the kettle of the tower, so through the PV5. And on the right here is something for the reflux. So this one is for the reflux, and this one is for the product on top. And this one is actually, after reboiler, is the liquid for the bottom product. So now we noticed the liquid level meter here for the L1. L1, that means the level in the feed tag container. Okay, so now it's the 264.2 or line, whatever. So we have to transfer the liquid or the raw material from the feed tag to the kettle of the chowder. And the kettle of the chowder, we have the right now it's a 100 millimeter. That means that it already has some liquid in this kettle, as well as that you may notice that from the overhead product receiver, now it has a figure like the 810.2, and from the bottom receiver now all have some figures, but these figures are actually the zero figure. Okay, so because we have some instrument to try to measuring the remained liquid in this container. However, the instrument may not be zero in that case. So you may consider this one as zero. Okay, 810.0.2, that means zero in this case, because that liquid is actually in the pipeline but not in the container. Okay, so this one you can consider it as 0 point. So anyway, we try to deliver the liquid from the feed tag to the kettle firstly. So there will be two kinds of alarm message. First one is just the alarm. You can do something after the pop-up comes, and you just do something to try to eliminate it. And another alarm message means directly showing you that your operation is wrong. So that will make your score deduction directly. Okay, so something like if we try to start the pump right now, we can click the start right now. But as you may notice, that the valves before the pump is closed, so is actually the wrong operation. So in this case, there will be a pop-up comes. That means a feed pump startup operation is not compliant. Please check. So in this case, your score will be deducted. Okay, directly, because it's a wrong operation. But some other message is alarm. That's okay. And after maybe 30 minutes or 30 seconds later, and if you did do something, there will be no effect for your score. So before we start this pump, we have to open the valve before the pump and make sure that the valves after the pump is all of them are closed. Like we have to check PV5, PV4, PV3, and FV1 are all closed. After that, we can start the pump. Okay. And before we start the pump, we have to set the correct frequency for the pump. it should be bigger than 20 hertz. So in this case, we can enter 40 here. And 40 means 40% opening or start for this pump. And the 100% opening, that is 50 per hertz. And 40% opening, that means 20 hertz in that case. So at least 20 hertz. So it should be bigger than 20 hertz. Okay. Now it's only feeding because the level meter in this kettle should remain in some range that is about 360 to 460. Okay, should contain in this range. If that is bigger than 460, there will be another message, alarm message. So in that case, you have to do something to eliminate the alarm message. Or if it is smaller than 360, the liquid in the kettle is not enough. After we really do the experiment, maybe the liquid in the kettle is not enough in that case because it will turn into vapor. So that is a harm to the experiment and also for the device, harm for the device. So that we have to not do that. So after that, make sure before when we do the feeding process operation, I think the frequency for the feed pump should be as small as possible. Okay, because if we open it 100% and 50 per hertz, the liquid moved into the kettle will be very fast. Okay, that is hard to control. So we can choose the 40%. That's okay. Okay. Now we just start it. And after we started in the red will turn into green. In the green, that means it's already open or start. And then we can open PV5 and make sure that the L3 here, L3 that means the level meter for the kettle or for the reboiler. Okay, after minutes, when we see it start bigger, okay, maybe 40 is not enough. Okay, well, maybe 40, 50. Okay. Or maybe 60. Okay, now you notice that the level meter is increasing. Okay, make sure this figure is close to 360 to 460, and close the PV5 as soon as possible if the figure close to 360. Okay, now I think it's time to stop. So right now we stop, close the PV5 valve, and now we notice that in the kettle of the destination tower, now it has the level meter indicated that the 370 millimeter liquid in the kettle, and then we can stop the pump. Okay. So finish feeding. And also for the PV7, close it. So what I try to say is that we have to make the feeding a little bit slower. Okay, otherwise the liquid level in the kettle is hard to control. Okay, so we just use the 60% opening for the uh, feed pump. And after that, if your liquid level is bigger than 460, you may use PV8 to and also the feed pump to make the liquid in the kettle back into the feed tank. Simply open the PV8 and also PV1, okay, to this link, to this pipeline, and make sure the liquid back into the feed tank. And after that, and you can feed again. So now we have the enough liquid in the container in the kettle. Now we have to, after heating, the liquid will turn into uh, vapor and go through the distillation tower. So now we can start heating right now. And then we have the SV here, PV here, and the MV here. These things are for the control for the uh, E2 here for the heating reboiler. Uh, before you turn on the reboiler, make sure that the MV here is 0. Okay. As here SV, that means the set value. PV, that's a process value, and MV, that is manipulated value. So for the manual mode, here is the M signal here. For the manual mode, actually the SV and MPV are the same. Okay, but for the auto manual, we can set some value here for the set value, and the PV value will close to the PV SV value automatically. However, for this control, for this computation, we only use a mode value. Uh, so actually, SV and PV are the same or the identical in the entire time. So MV is how we open it, how we control it. Is a kind is a what's the degree of the maybe it's a degree of the valve opening or the uh, electricity uh, cost for uh, some like the reboiler. Okay, what percent? 0% to 100%. Now we set it to we cannot set it right now because we have to uh, open the turn on the heater under the MV here is 0. Okay, in that case we can open it. Otherwise, and then we can set it to some degree. Okay, right now I think 35 degrees okay, because we have to make sure that the actual uh, kilo we have to make sure that this value is smaller than 3.5. 3.5. Okay, so it's kind of a linear relationship, uh, 35 to the 3.2 or 3. And if we turn into maybe like 40, so if we give more powder for the reboiler, of course, the liquid will temperature will increasing faster and turn into the vapor. However, that will be harm to the device. So, so we set the limit that is smaller than 3.5. But we can do it and for mistake to show you. And so what we can do to eliminate the alarm. So now we could change it to 40 and it says the heating powder E1 is above the upper limit. Please adjust it properly. So this is an alarm message. So if you respond it quickly, there will be no effect to your score. Okay, we simply change it into 35. That's okay. And now we notice the the actual kilowatt is smaller than 3.5. And we can close the reboiler right now because I want to show you what's there will be more wrong message to show you. So right now we close the reboiler and we keep the MV value into some not zero value, and we try to turn on the reboiler, no heating. So we just click this one, and it will tell you that reboiler heater startup operation is not compliant. Please check. Because we not set it to zero before we started the reboiler, so we have to do that again. That is actually the uh, wrong operation procedure. So in that case, your score will be deducted directly. Okay. So after we set it to zero, we can turn on the heater. And now it will be turned into green. Um, because it's a network it's network uh, control. So there will be some lag after you click the button and the real on-site um, status changes. There will be some time there. So that is a lag. Just familiar with that. Maybe 5 seconds or maybe longer. I don't know, because the actually you are from different countries, and maybe the lag is is bigger than I have right now. For me, I only have maybe 2 to 3 seconds. So now we can change it into 35. So in this case, we just wait the temperature increasing, and for the liquid in the kettle, and the liquid will turn into vapor, and finally to the top of the tower. We can see the temperature trend here. Um, right now for the T4 is this value, and we just this. Okay. You may notice that the temperature is increased. Okay, is increasing. Okay, is increasing. After the temperature for the bottom and the T4 is stable, that means the all the liquid from not all these um, is stable, just stable. Okay, the liquid and the vapor are in the equilibrium condition for the bottom, and also we have to wait for each tree, liquid and the vapor, they have to be in the equilibrium status. So it may be cost 20 minutes or 10 to 20 minutes after all the trees are in the stable status. Um, for this experiment, for the computation, we want to contain enough specified ethanol from the top, and that is a top one um, task for our computation. Another one is we want to make sure that all your operation is standard. And the third one is we have to consider the energy consumption, including the powder consumption and also the water consumption. Right now, you may notice that I didn't open the um, condensed water from the top. So, but for the distillation tower, before we start the reboiler, we have to open the condensed water right now. Okay, because we considering the powder consumption for this computation, so you may turn on the condensed water later than the start of the reboiler. Uh, but before the uh, you have to open the condensed water at least when the T3 is bigger than 70 degree. That means if the T3 is bigger than 70 degree and you still not open the turn on the condensed water, your score will be deducted. Okay, so in that case, because it's only testing, I just open it right now. Set it into 100. And open the PV10. Make sure that there will be some condensed water go to the overhead condenser. Okay. As I said, you can turn on it later. At least the temperature of the T3 is smaller than 70 degree. And of course, during the experiment, you can change the opening of the condensed water because we're considering the powder consumption. Okay. And how we measure how we consider the top product is okay or not. We define the condensate product concentration by considering or noticing the T1 value here. Because for each tree, the liquid and the vapor will be in some, after stable, will be in some equilibrium status. In that case, the temperature can indicate the uh, concentration of the mixture in that case. So we not use some other kind of a measurement instrument to try to measure the product concentration, component concentration. We only define the we only use the top temperature to indicate whether the product is acceptable or not. For instance, we may define the temperature from the top to be 80 degree. In that case, or to around 80 degree. In that case, you can try to control the reflux flow rate and also the product flow rate and also the condensed water consumption flow rate to control the T1, okay, to make sure that the temperature from the top is close to the the 80 degree. But right now, 80 degrees is just what I said for this testing. For the real experiment, for the real computation, there will be a specified value for you. You just make sure that you get the correct value before you really do the experiment, the computation. So right now it's just waiting. We can see the temperature for the T4 is increasing. However, the T3 and T2 are not changed because the vapor just not go upstream enough to the specified tree position. So we check like the temperature here is already changing for the T3, T4, but T2 and T3, as you noticed, are still stable. Um, uh, so of course you can increase in the reboiner powder consumption to make it bigger. However, make sure that your uh, make sure that this value is smaller than 3.5 because the value here will be changeable. Okay, it's not stable actually. So I think 35 is the biggest one, and at least for this device. This device is each team will have the uh, one device. Okay, maybe for this device, 35 is the biggest value for the limit. Okay, proper limit. But for other device, maybe this value is different. And also for the destination for the commutations, we will have to make sure that the enough ethanol product from the top is obtained. So first thing is for the temperature, because for the T1 temperature, because T1 temperature indicates the concentration of the product. Then another one is amount of the product. So or the top yield. So how much we have to obtain during the experiment. Right now it's zero. We for the L5 for the liquid obtained from the overhead product receiver. Okay, like for the task, we will give you a specific value. Like we will have tell you that you have to obtain at least 1/8 millimeter product from the top. In that case, you have to add 180 to 81.3 because right now 81.2 is the 0 degree. It's a zero level, and you have to add 81 to 180. Okay, 180 is a specified value we will give you. And for the distillation operation, right now you may consider it as a batch distillation because many uh, raw materials are transferred into the kettle. But for the distillation operation, you can also use the uh, continuous distillation. You can use this pipeline. Okay, the feed tag to pivot 7 and to feed pump and go to the left and go to FV1 and go to the preheater and choose the PV3 or PV4 a proper inlet position to inlet to go to make sure that the raw materials into the distillation tower continuous distillation. You can choose continuous distillation or batch distillation, both are right, but on and for mm, for the distillation and um, for the continuous distillation and the batch distillation, maybe the time consumption, power consumption, and water consumption is different. So you can choose it by yourself. Which one is better? Okay. Mm. For the top concentration, I would like to say it again. For the top product concentration, we only define it by T1. Okay. If the T1 temperature is around some specific value the commit give you, that means the top product is acceptable. And actually, if the temperature from the top, if it is smaller than some like 76, then it's a pure ethanol. But that is not the task we want to have. So like we give you the value is 80. So you have to make sure uh, the concentration and the temperature is in this range, is around 80. If it is far from the 80 degree, it's not acceptable. Okay, uh, even the ethanol concentration may be even purer, but that is not acceptable. We have to make sure that the concentrate T1 is close to some temperature, and that temperature we will give you later. So now we just wait the temperature for T3, T2, T1, and also for T4 is stable and is close to the some specific value. Also here we have the preheater. The preheater, that means you can, when you do the continuous desalination, you can heat the inert raw material. However, the preheater energy consumption will also be considered as the power consumption for the whole process, for the whole computation. So you may consider if we open the turn on the heater for the preheater or not during the experiment. So for the reboiler energy consumption, preheater energy consumption, and also for the condensate water consumption are all considered as the energy consumption, powder consumption and water consumptions. And the standard operation process, something like if you try to open some pump, you have to make sure that the valves before the pump is all open, and the valves after the pump is all closed before you start the pump. Click the start this value, this button. Right now we notice that T3 temperature is increasing. Okay, so that means the vapor already reach this level. Yeah, we made back to the uh, live video for the on-site device. Actually, from this eye hole, we can see the uh, liquid and the vapor contact status in this hole. However, maybe from this angle, it's not clear to see that. Okay. So you may notice the here we have the on-site level meter. That's actually the same. It's I think it's right now it's close to 360. Okay, we just uh, back to the control panel or the flow chart. So for the reflux flow rate control is actually we have the reflux pump. However, this pump, the name is a reflux pump, but it's actually I think it's the condensate water, a condensate liquid pump, because this pump there will be two directions. One direction to the tower, one direction to the overhead product receiver. It's one pump to control both. Okay, we don't have two pumps here, uh, not reflux pump and the product pump. We only have one pump to control both. And this PV2 is linked to the flow rate, flow meter. And this LV1 valve is linked to the condensate receiver's level meter. Okay, and there will be another very important and a very hard control things for this experiment, for this computation, is how we control the level uh, in the condensate receiver. Okay, right now it's 73.7, and it should be around one. I think it should be around 80 to 260. Okay, it should be bigger than 80 and smaller than 260. And I'm sorry. And okay, right now you may notice that there is already some liquid into the level into the condensate receiver, and we have to make sure that some liquid will back to the tower. Okay, then in that case we have to start the pump, reflux pump, or the condensate water or condensate liquid pump. We first set the frequency into maybe 60, 40, okay, maybe 40. And then we can start it. And then we can open this FV2, and we simply right now is fully opened it. Okay, in that case, the condensate liquid will go through this way back to the tower. And you can notice that there will be, oh, okay, F2. Because each flow meter has its range, and the range will give you, and the we I think we already give you all kind of meters range, because this is rotometer, so it has range. So now it means it's already close uh, close to the top limit. So we have to close it as soon as possible. Right now it's just the alarm message, but if you not respond it quickly, your score will be limited. I think that 90 is still not big. Please make sure that the uh, this manipulate value and it's to the uh, actually it's the opening degree for this valve. So this opening degree of this valve is not has the linear relationship to the actual flow rate. So maybe for as I just as it just said, maybe from 90 to 80, the flow rate opening degree, the flow rate changes from 70 to 10. However, if we change it into 70 for the manipulated value, but maybe the uh, actual flow rate will change from 10 to 0 in that case, even, okay? Because there is no linear relationship, okay? So what are we doing right now is we want to make the condensate liquid. So right now, because it's a vapor from the top and go to the condenser, overhead condenser, and we make the liquid back to the tower. So the liquid back to the tower and the vapor going to the receiver will be equal to each other. In that case, the level in the condensate receiver can be stable. So right now you may notice the level meter for the L4 for the condensate receiver is still increasing. So we have to open enlarge the uh, opening degree for the FV2. So right now it's 88.3, but the level meter for the condensate receiver is still increasing. So in that case, we have to open it a little bit bigger. Okay. Or even bigger. Because this value L4 should be smaller than 260. Otherwise, if the L4 is bigger than 260, the reboiler will ultimately closed. Okay, we just maybe we just see that error happened. Okay, to see what we should do after the L4 is bigger than 260. There will be pop-up alarm message shown, and we have to do something in that case. Right now, right now you see high condensate receiver level alarm. The reboiler electric has a heater has stopped. Okay, so in that case, first we have to open the degree of the valve bigger. Okay, maybe 95, and we have to restart the reboiler, right? But right now you may notice the here if we okay, it's bigger than limit. In that case, maybe 90. Okay. Because if the uh, actual value is bigger than the uh, rotometer limitation, so maybe we can't get the actual value of the on-site flow rate. Now it's 70, but it's actually bigger than 70. The actual flow rate is bigger than 70, right? Now we notice the flow the level meter is quite stable right now. And now we have to open the restart the reboiner. And if we directly click this button, and it will give us another pop-up wrong message. Okay, because it tells that reboiner heater startup operation is not compliant. Please check. So what's wrong with that? Because here MV is not zero, so we have to type it into zero, and then we start it. And then we just change it into 35. Okay, in that case, I think right now we notice that the level from the for the F0 for the L4 is decreasing very quickly. That because the temperature from the T1 from the top of the column is decreasing. So that will be no vapor into the condenser to this heat exchanger. So and we still open FV2, so more liquid will back to the tower, but no vapor in this receiver in that case. So we just wait the temperature of the T1 back to some temperature, and there will be more vapor and into the condenser into this heat exchanger again. Okay, now we see there will be liquid back, okay, into the condenser receiver. I think maybe 85. Yeah. So you may consider this process, this operation, as the total reflux. Okay, because for the destination tower operation, there will be a total reflux operation, and a partial reflux operation. Right now, it's a total reflux, and I think that's okay for the total reflux. For the procedure, for the normal operation, maybe total reflux takes about 30 or 20 minutes, but for our computation, I think that's the time cost for the total reflux operation could be very quickly, could be very limited. Maybe 10, maybe 5 minutes, that's enough, I think. So we just noticed the L4 is still increasing a little bit. So it's quite stable anyway. So right now we can open the valve for the uh, overhead product receiver. Okay, for the product top product, we simply open this change this value. Maybe I think 20. So after we change it into 20, now we notice the here F3 that is for the uh, top product. Okay, so some liquid, some condensed liquid will go to this link and go to the overhead product receiver. However, 1 liter per hour is not enough for this computation because we have to obtain enough uh, acceptable uh, top product in the overhead product receiver. Okay, maybe we have to make it bigger. Okay, so maybe 40. Now we said it has 1.3 liter per hour for the output of the top product, and you can sum the uh, product and the reflux together. So in that case, we can a little bit decrease the opening for the product for the reflux, okay, and continue to increase the product opening. So actually, if we change the flow rate for the reflux and the flow rate for the product, uh, this is actually we change the reflux ratio. In that case, the temperature from the top, the T1 will be changed. Okay, because the reflux ratio changes, the T1 will be changed. And also we can change the condensed water here, water consumption here. Now it's 100% opening. And if we change it, the T5 and also the T6 will be changed. So in that case, the T1 will also be changed. So you can define it better later, how much it should be changed to make sure that T1 is in some specific range. And also the reboiler energy consumption, the heater, can also be changed. Uh, so this one and the water the energy consumption for uh, the heating for the reboiler and also for the uh, water consumption degree, opening degree, and also the reflux ratio, all these parameters can change and will be affected to the T1 value. Now I think maybe more can be used through that. Okay, so now it's for the top of, okay, F3 is bigger than, I think maybe we cannot open it at this big, maybe 70. So the range for each rotometer and other kind of meters, we already give you the range for each kind of meter. So you can find from your user's guide or the other electric um, material. Okay. So maybe 70 is still bigger, maybe 60. Now we notice the uh, level meter for the overhead product receiver is increasing, right? And now we want to, this is for the top product, uh, how we change it, how we control the T1 value. But how we control, actually how we control the T1 value, I will give you no guide, okay? But you can control, as I said, the reboiler heating, the reflux ratio, and also the water consumption to change the T1 value. Now we want to do the, I think is a little bit bigger. Okay, maybe this one is smaller. Now we want to do something for the continuous distillation. In that case, we have to open PV3 first name and uh, make sure that feed pump, okay, is okay. Make sure the valves after the pump is all closed. FV1, PV4, PV5, PV7, PV3 closed. And we want to go to this link, okay? Go to this link. So PV1, we maybe opened it to be something like 50% open. And then we choose the correct, we choose the proper inlet position, PV3 or PV4. Now I just choose it randomly right now. But you, during the computation, you have to consider which one is proper. Okay. So right now we noticed that the even we open the PV FV1 and the PV4, but there is no inlet, no feeding, right? Because from the F1 we read it's already 0 liter per hour. That is because the pump, the feed pump, the frequency is quite small. Uh, because the height of the PV3, PV4, and the PV5 is different. For the feed to the chowder uh, kettle, maybe 30 hertz is okay, is enough. But for higher inlet position, maybe this uh, hertz is not enough. So we have to increase it. Okay, maybe 80. Now we have see even we don't change it. Now it's already have something. That because why that happened? So why we don't change the frequency of the pump? It cost them maybe few seconds, or even 1 minute later that there is a one that is feeding. So why there is a lag? That is because the preheater. Okay, preheater actually there is not enough liquid in the preheater until the liquid uh, contained from the bottom to the top, and there is enough liquid in the preheater, then the liquid will go through this pipeline. Okay, so that is time consumption is for the full of the preheater. The liquid be full of the preheater. After that, the liquid can go out and go into the. Okay, that means the F1 is too big. So in that case, we may close it a little bit. Okay, still too big. So in that case, you can change both. You can change the frequency of the feed pump, or you can close the FV1 a little bit to make sure that the inlet feeding is not that big. Okay, and please notice that the opening of the valve is not has a linear degree, a relationship of the real actually flow rate. Okay, so right now I think everything is okay. So for the heating, for the preheater, um, for today's experiment, for this today's testing, I don't open it. I don't turn on it. But for you, you can turn on it. Okay, maybe like you can maybe set it into 8 40% is not enough. And you later the temperature for the preheater will be increased. Okay, but as I said, the energy consumption for the preheater also be considered as the power consumption. So it's you to decide whether we turn on the preheater or not. Maybe right now I just close it. Okay. Uh, yeah, it's not correct. Zero. 为什么这么少？And for the feeding, the range, the feeding flow rate should be bigger than 0.5. Okay, if it is smaller than 0.5, it's not allowable. Maybe I just open this a little bit, increase the frequency of the pump. That's much easier to control. Okay, so you can change this one. Okay, too big. So you can change both the FV1 opening or the frequency of the pump to change the inlet flow rate. Anyway, you can this is how we do the continuous destination. And for the bottom product, the concentration of the bottom product we will not consider it, but you will do some bottom product resave. Okay, you have to do some not resave, obtain. Yeah, obtain. You have to obtain some bottom product, but the concentration for the bottom product will not consider that. Okay, maybe this one is still too small. And how we do that? So here we have the bottoms pump, and also we have the start here. Before we click start this button, we have to check if the valves before the bottoms pump is open or not, and the valves after the pump is open or not. Okay. For instance, if I want to try to start this one, it's it give us some alarm probes. Bottoms pump startup operation is not compliant. Please check. That's because the PV9 is not open. Okay, the valves before the pump should be open before we start the pump. Oh, so we may notice the L4 is a level is a little bit bigger. So in that case, we may open this one. Open the. Oh yeah, okay, we can't. I think maybe open this one a little bit. Yeah. So maybe this one a little bit bigger. So I just open the opening, increasing the opening for both valves, FV2 and LV1. Okay, try to make the level meter for the condensative receiver a little bit smaller. Okay, now we see it's decreasing. And I want to open this one bigger, but why it's not it's actually it's quite hard to control. Okay, you have to have more time to be familiar with this system. For after today's trial, you will have another chance to do that, do the computation, do the test again. So you have two test time. Now, oh, okay. Now I want to open this one. So here L3 is actually linked to the pump. Okay, so we simply open this one, maybe 40, not 40, yeah, 40 maybe. After we call it 40 because 100% is to the 50 per hertz. So 40 is to 20 hertz. Okay. After that, we can start the bottom pump. It's still small. Okay. I think it's too big. It's too big. Uh, oh yeah, maybe it's too big. And the inlet, actually the feeding right now is too small. We have to open it a bit. We have to increasing the feeding right now. Right now it's only 3.0, but I want to adjust it into maybe 5. Because the output, now you may notice that the output of this system is a 5.4, 5.4, and the 5.2 from the bottom. From the top is 5.3. From the bottom is 5.1. And sum together is bigger than 10 liter per hour. But the inlet for the feeding is only 3.2. So I think something should I should do something. And also, you may notice that though the level meter for the L4 is decreasing, so we have to close it a little bit. It's actually closed faster. How much? 75? Yeah, maybe 4 to 50. I don't know. So right now we have some liquid contained uh, in the overhead product receiver. Okay, and also after you get enough uh, liquid top product from the overhead product receiver, and then we can. So why it's maybe 50. After you get enough liquid in the overhead product receiver, then you can finish your experiment. The time consumption for the computation is 90 minutes, and for 85 minutes you may stop everything in that because because the shutdown operation is also a standard um, operation process, which will be considered as the score, one part of the score. So how we stop that? Right now, I didn't get enough. I don't get enough liquid top product, but now I have to close it. I have to stop it because today is only the test. Okay, so first we have to close the. I think now first I have to close feeding. Okay, close feeding, and also close this one into 0. Close the valves after the pump, and close the pump, feed pump, and also close the uh, inlet, and also close this one, and also close this one. And after that, we have to close the heating. Okay, close heating. Uh, the steps I um, do the experiment today maybe is not the standard operation procedure. So you have to consider it by yourself. What's a sequence to start and stop the pump, and also the sequence of the open and the turn off the valves for each. Okay, whatever. Uh, and then I want to close the valves for product as well as for the reflux, and then close the reflux pump. And after that, we come back to the screen, this web page, and for the okay, for the condensed water, you may not. It's by your consideration. You may not close it, okay, because the temperature for the tower right now is bigger than 70, okay, especially T3. Right now it's bigger than 70, so you may not turn off the uh, condensed water, okay. We simply stop it. And before you click this end button, you have to tell the referee that you will end the experiment, end the computation, because uh, once you click this button, that's the end of that's really the end of your experiment. There will be no more chance to do the operation, to do the control again. Okay, so right now I just close it. Okay. So I think that's all for okay. I think that's all for today's demonstration video. And if you have any questions, please tell us through the email or other kind of anyway, you can contact us. Okay, thank you so much.